Mm-hmm. So it's that was one of the reasons where they got the thing of the Star of Bethlehem, so you can blame Venus and Jupiter for that by the sounds of things.
Probably. Or maybe even a third.
Yeah, it's possible.
In a conjunction.
Yeah, it's certainly not
I've read various stories about what the Star of Bethlehem was. Some people thought it was a comet, but comets were kind of known, and but apparently these three wise men from the east would have been astronomers or astrologers as they were in the day, and would have known about this conjunction and what part of the sky it was in, and would have ascertained certain meanings from that. I did read a report, I can't remember who it was, but from shepherds watching their flocks at night, on what time of the year they would do that. And basically, this guy, and I can't remember his name, he put all this evidence together, and he came up, I can't remember the exact date, but he decided from the evidence that there was with conjunctions and other passages in the Bible like that, and shepherds watching their flocks at night and things like that, that Jesus was born on something like the 3rd of September
or something. I've heard that one too.
Or something like
exactly
that.
So.
But how do we know?
Yeah, well, it's good.
If he was... Well, we have to trust it.
We have to trust
ever born.
That's the benchmark for nowadays, anyway. So going back,
maybe we'll do another a bit of research on this.
Everywhere I
find out, but I mean, nobody claims that he was born on the 25th of December.
No, and I think, but it doesn't really matter. Yeah, tail end of the year. Imagine having Christmas in September.
Well, if you're in the southern hemisphere, and it's December. Well, it's obviously 25th of December, but. I was in New Zealand at 25th of Yes, first quarter. So, sunrise tomorrow in Dublin will be at 8:39 a.m., which is a whole 1 minute earlier than a week ago. Local noon is at 12:29 p.m., which is 3 minutes later than a week ago.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio, AFM Radio. 3.
Hello and welcome to York University Astronomy and Astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. I will be your host this evening. This is Dr. Elena Hyde, and I am broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is, in fact, Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT, if that's more your style. The York Universe production works in concert with our online public viewing program run by the amazing Observatory team, which is online right now, which is between 9 to 10 local Toronto time. So they're actually, if you're listening to this live, they are running at the same time as this broadcast, which means you can head on over to our website, yorku.ca/science/observatory, and follow the links to OPV online public viewing, or just click on the YouTube link to join in the live chat. They've got all kinds of great images up. I'm not sure if we're able to do any live imaging tonight, but they always have fabulous archive images and wonderful chat over there for everyone to join with. So as a final little note, this broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. If you have any questions or comments on our past shows or suggestions for future topics, please email us at observe@yorku.ca. And you can always connect with us on Twitter, where the handle is @York Observatory, or on Instagram with the handle York U Observatory, just to be a little different, and Facebook at Allan I. Carswell Obs. All of our programs are free, but you can make a donation over on that website I mentioned before, yorku.ca/science/observatory. Our observatory crew is, in fact, monitoring the YouTube chat room for any questions and posting content. The current weather is a bit cloudy, so we'll see how it goes. I know that clouds are never a friend to astronomers, and this broadcast is going to be a little different. As you might have noticed, seems like I'm all by myself on this show. Actually, we're going to have an awesome interview with Dr. John Moores later on in this very broadcast. But to get started, I'm going to do a bit of a topsy-turvy sort of broadcast. We're going to talk a little bit about some news, what's up in the sky, and a really wonderful announcement, our first official astronomer in residence announcement of 2023. I don't know if I was one of those other radio shows, we'd have a little horn, and we would probably be broadcasting, I don't know, some sort of cool space music to announce it. But the astronomer in residence program is, in fact, running again. So if you are out in Toronto this evening, there's quite a show going on in the sky right now. You have a beautiful red planet Mars sitting right about, well, not totally zenith, but it's right about overhead. And if you've got good binoculars or a reasonable telescope, you can still catch that green comet, which is pretty close to the planet Mars. And there have been some pictures out there on, I think, Astronomy Picture of the Day, if I'm not mistaken, although I might be, and you can tell me in comments. The picture of Mars as the comet flies by next to it, it already had its closest approach, but it's still very, very nearby, just to the west and south of Mars. Comet C2022E3 ZTF is, of course, the comet I mean. It's down to magnitude 6.88, so it's getting fainter and fainter and fainter, but the tail is pretty spectacular. So if you do have a clear view and good telescope, you can make it out. If you don't have a telescope with you, don't worry. It's actually quite nice to still see the beautiful red planet Mars up there sparkling. And if you want some contrast, you can always look to the blue Pleiades, which are just to the west of Mars this evening. So actually tonight we have a little bit of a red, blue, and green show going on. Red, of course, being the planet Mars, blue being the Pleiades, and the green being the green comet, which you can't actually see with your naked eye. So it's not, two of those objects are visible to your naked eye, of course, the Pleiades and Mars, nice and bright. Mars isn't at its closest point to Earth, but it is at a reasonable magnitude of 0.08. So nice, nice full Mars to look at. Almost full face. And just as a little side note, one of the fun things is if you do have binoculars, you can watch, because the outer planets do every once in a while get a little bit of a phase to them. So lots of fun stuff going on, of course, up in the sky tonight. So we're going to do a little bit of an extended, shall I say, nighttime viewing recommendation area, because there because, of course, tomorrow is Valentine's Day. And when we have Valentine's Day in astronomy, of course, we start looking for all of the heart-shaped objects in space and, making beautiful astrophotography for the most part. I, in fact, heard a rumor that there was a new heart-shaped nebula that JWST had gotten a picture of, but I have yet to confirm that. However, I will point out that if you're out looking at Mars, you won't be able to see this with your naked eye, but there's some wonderful heart-shaped features on Mars, in fact. So it's a red planet. I like to say that it's sort of the perfect Valentine's Day observing target. It actually has a heart-shaped feature in Arabia Terra, which was taken on the 23rd of May back in 2010. Arabia Terra being one of the sort of landscape features on Mars. The dark and light features of Mars you can see if you've got a reasonable telescope. They're called albedo features. And of course, if you have things like impact craters, you can get darker material on the surface being blown away and brighter material beneath being revealed. And that's actually what's happened in Arabia Terra to form this sort of little heart-shaped feature where some of the material sort of flowed down from a crater's impact to form what looked like from satellite images as a bit of a heart. So, I mean, obviously don't believe everything you see from satellite imaging because, of course, the shadows can be very misleading. But if you're out tonight looking at Mars, you can spare an extra thought for its heart-shaped feature because, of course, tomorrow is Valentine's Day. And I'll just give a little extra shout out to our observatory crew. Tomorrow, on February 14th, if you are in the Toronto area or near York University, the observatory is having a special Valentine's Day tour. That's right, an observing tour. It is astronomy focused, so it is, of course, about the astronomy of various heart-shaped objects in space, nebulae, craters, and that kind of thing. Of course, the heart on Pluto is a big favorite of everyone's. And if you get a chance to come by, the tour is in fact open to the public. So you can go to our website if you missed it. If you missed it before, it's yorku.ca/science/observatory. Click on the Eventbrite ticket link and grab your tickets for a Valentine's Day tour. I believe they're starting about 5:30 p.m. Eastern time, and we have a little bit of a Valentine's Day, lightly Valentine's Day themed. A few heart-shaped nebulae will be discussed, and we have a slideshow of sort of red imaging objects, so infrared objects and objects that are imaged in the visible as red. The Orion Nebula is a wonderful gassy structure. I'm not sure if it's necessarily a Valentine's Day thing I'm saying, but it's of course a lovely image of a star forming region. And we have a whole slew of slides for astronomical objects and their descriptions that our crew have put together, and a few decorations. I believe there's going to be a small scavenger hunt. Minimal prizes, sorry, but it is going to be tomorrow night at the observatory. So if you are a big fan of telescopes or tours, or just want to have a look through the 1 meter, if it's clear, the February 14th Valentine's Day event should be pretty fun. And of course, the Valentine's theme is a very, very light one. We have a lot of things in the sky that are associated with myth and legend, including legends of the goddess Venus, or the Roman goddess of love, and there's a literal planet named after this one. So it's only natural to connect your fiction and your science once in a while. If you're looking for heart-shaped nebulae, there is in fact a heart-shaped nebula about 7,500 light years away from us. So all of this and more. Tomorrow is Valentine's Day. I think we can wax a bit philosophical on astronomical objects once in a while. So tonight is, as I mentioned, a little bit of a different kind of broadcast. This is going to be our What's Up in the Sky portion. We'll talk a little bit about what you can see, what you can look forward to. A lot of the interesting nebulae and galaxies and features that you'll hear discussed in astronomy are not going to be visible to the naked eye. If you're outside just looking at in a park or a reasonably dark sky site, you want to be careful that you're looking for the really, really bright objects. So I keep saying Mars because, of course, it's nice and bright and red. If you wanted to do a little bit of a red object tour tomorrow on the 14th, you could actually go. So if this is, so we're at 9 p.m. Eastern time right now. If we go on to the February 14th around this same time, so 9 p.m. Eastern time, you can actually get a little mini red object tour that you can see with your naked eye by starting at Mars and then going west and south to Aldebaran, which is a little bit red, and then down south to Betelgeuse, which is quite a red object. And if you find that sort of red triangle, you can then navigate up to the Pleiades, which is a blue object, or even down to a few clusters. If you've got some binoculars, you can perhaps get to some of the open clusters. And if you go from Betelgeuse, which is, a nice red star, you can go just a little bit south and west and land on, of course, that Orion Nebula that I was mentioning before. And there's all kinds of interesting things over there. The Orion Cluster, the Orion Nebula, lots of great fun. And that's a great one for binoculars under a good dark sky site. Other things can be a little harder to find. So the heart-shaped feature on Mars, you will not be able to see unless you are literally in orbit around the planet. So don't worry about not being able to see that one if you bust out your binoculars tomorrow or tonight. So heart-shaped nebulae, there is actually, I will call out, a nebula in astronomy, which is called the Heart Nebula. It's about 7,500 light years away, and this is one that is not going to be visible to your naked eye. It's in the constellation Cassiopeia, and it's visible in the northern hemisphere all year round. So it technically will be on top of us both tonight and tomorrow. You will not be able to see it with your naked eye, however. If you look at some pictures of Hubble Space Telescope images, or if somehow we are able to get the James Webb Space Telescope to point at it, this nebula has a lovely sort of pinkish color due to ionized hydrogen gas and some lovely dark clouds of dust going around it. So there's a lot of really, really fun craters and regions out there in the solar system that are in fact heart-shaped or have hearts in them. And this is in fact due to humans being very, very good at pattern finding. It's been mentioned before just how good we are at seeing, especially faces in things. But when there's a pattern that we can all easily recognize, it makes it something that our eyes will look for. And this is how constellations came to be. We wanted patterns in the sky that would allow us to create references for, of course, navigation and time telling and calendars and all kinds of really practical purposes. But it does mean that we're very, very good at seeing shapes where there really aren't any. So, of course, hearts are a very common shape nowadays, and it's easy for us to find them. But when you're out there looking for any kind of shape, keep in mind that you can find pretty much what you're looking for if it's a nice, simple shape. And the constellations of the IAU that are drawn on most of your star charts are just simple shapes that used to be recognizable. Some of them still are. Some of them more than others now, I suppose I should say. So out in the night sky, we've got a lot of wonderful stuff, some of which you can see, some of which will be too faint to see, but it will all be up there on top of us tonight and tomorrow night in any case. I will give a special mention for as far as Valentine's Day and hearts go, one of the, I suppose, most endearing hearts that has come about in astronomy in recent years is, of course, the heart-shaped region of Pluto. And this is, come about because of the high resolution images that we were able to take with the New Horizons probe. Now, Pluto, for all of our knowledge of Pluto up until very recently, it was a dot of light, and it became a blurry dot of light and a bigger blurry dot of light, but we didn't really know what the surface looked like until it had an actual flyby. So here's your insert your favorite argument for satellite exploration of the solar system here, because flying by it, we found out so many amazing things about Pluto, but it's got an absolutely striking heart-shaped region across its lower hemisphere. And it actually was renamed, so it's not called heart-shaped region, but it is very, very much heart-shaped, and it's called Sputnik Planitia, I believe is the current name. And it's was named by the New Horizons mission team. We sort of hand out the official names, got to hand out the official names for the dwarf planet features. And it's smooth heart-shaped region is sort of a lighter brown, if you will, than the rest of the surface. So if you are able to get a high res of that, high res in astronomy is kind of a requirement, because once you zoom in, you get so many more details. But the Sputnik Planitia, we think it's, as I say, it's heart-shaped, but currently they think that it was formed when a large object slammed into the young Pluto. We don't know exactly how large it would have been, because we don't really know the depth of that plane. The basin appears to be filled with sort of volatile ices, of course, Pluto being incredibly cold. I suppose you could make some sort of Valentine's Day analogy if you wanted to, but the icy heart of Pluto is out there, and it looks absolutely lovely. And of course, this being a newer feature on the surface means that it doesn't have a lot of craters, and this is something that's actually really fun to look at anywhere in the solar system. And you can even start with the moon. Looking at less cratered surfaces means that kind of by default, they must be newer surfaces. Early in the formation of the solar system, we think that there were a lot of small objects going all kinds of directions, a lot of messiness, if you will. If you can think of it kind of a rotating disk of dust and small objects colliding until larger-ish objects were formed. And then, of course, you still get a lot of collisions until everything is cleared out. So early in the formation of the solar system, there's still a lot of stuff there because it hasn't all collided yet. So you get a lot of craters early on, and you get, the more craters you have, the kind of the older your surface must be. If you've resurfaced, maybe you're like Earth and you've got oceans, or you've got volcanoes, or you were hit by a giant object and had a basin with volatile ices that sort of melted and flattened out like Pluto did. So New Horizons didn't spot any impact craters across the plane of Pluto, which means that the ice on Pluto might be less than 10 million years old, or formed less than 10 million years ago, which is not that old for things in the solar system. Last I heard, they were actually thinking about renaming the heart-shaped region again. I couldn't find if they had, so I suppose leave that in the comments if you find out that they did actually manage to rename it once again. But there is a lot there for sure. So I hope everyone has been intrigued by heart-shaped objects and space in general. There's a lot out there to investigate, whether you're looking for heart-shaped craters or heart-shaped features caused by collisions. There's all kinds of choices. There's even some heart-shaped adjacent craters over on the moon, and of course, lots of interesting shapes on Mars. I think there's one that looks a little bit like a butterfly, but that might have just been me browsing around on the HiRISE site a little bit too much. So, as a reminder, I am telling you all about heart-shaped objects because, of course, tomorrow is Valentine's Day, and the observatory team is doing a special in-person tour event at the observatory. I believe they've just finished putting up decorations earlier today, so hopefully it's all ready to go for tomorrow evening, and we will be looking at different kinds of heart-shaped craters, nebulae, etc. All this and more. So let me go ahead and round off the heart-shaped astronomy discussion and say, I hope you all get a chance to check out at least one interesting object, and if you can get to only one, make it Mars, because it is the best planet, and it's up tonight, and it's red, and it has heart-shaped craters and heart-shaped features caused by craters. So I won't say that Mars is the best planet, but for Valentine's Day, there couldn't possibly be one better. Just asking for arguments in the comments now, I suppose. All right, everyone. So let's go ahead and move to past the Valentine's Day to the next big announcement. So there is another very important announcement that I would like to share with you all first. Starting this week, starting now, actually today, earlier today, the observatory, the Allan Carswell Observatory, has opened once again our incredibly popular and very successful Astronomer in Residence program. I am super excited, a little bit over-invested if I am being completely honest. So this program has only run once before in 2022. So we started it last year for the very, very first time. And this is an Astronomer in Residence program with Killarney Provincial Parks in Ontario, Canada. Anyone can apply who wants to be an astronomer in residence, but the residence is at Killarney Parks. So you have to physically go there to be the astronomer in residence. So if you're far outside of Ontario, you might want to think about the driving distance before you consider this, but it is a wonderful location for astronomy, especially in the summer. So this program is run over the summer sort of term, if you will, and it actually allows astronomers from all over to go up to the parks and run shows. So if you are the astronomer in residence, you get to use the Killarney Parks Observatory, which is two small scopes, and you get to run shows. There's hundreds and hundreds of people who come out to the parks, and so our astronomer in residences run daytime shows for sun observing, which is really fun. Nighttime shows about the constellations, nighttime shows star hopping or star gazing, and of course they have an amphitheater as well, which is just awesome. It's an outdoor amphitheater, so if you imagine kind of like a campsite with a lot of really awesome little camp wooden benches, and then a stage built in the trees, that's actually where they have you give presentations for astronomy. So if you're thinking about going camping up there over the summer, definitely look out for the Astronomer in Residence. And if you're thinking about applying to the Astronomer in Residence program, they are open. We are doing it again. It was a success, so I'm very happy. We have a limited number of stipends available, so it's not going to be a great way to make money, but it does come with a guaranteed lodging out at the parks, and you get to run shows out there for 1 week, 2 weeks, or 3 weeks, depending on what you apply for and what's available. You are required to be certified as an astronomer and able to use the telescope. So there are some technical questions we will ask you, but it's a great, great adventure. And if you are interested to see what happened last year, our website did get recently updated. So it's the same one I told you before, yorku.ca/science/observatory, but if you go /air, or if you click on Astronomer in Residence program, it will show you some of the astrophotography and the Astronomer in Residence blog, not just from this year, which hasn't started yet, to be honest, because we don't start until summertime, but also all of the blogs from last year. So I'd like to give a special shout out to the folks who came up during 2022, Quentin Wayrich, who was on this program just last week. Raj Sira, who did an amazing tour up there, only 1 week. I, of course, went up. I couldn't resist. Julie Tomei, who's been on our program many, many times, and I believe actually came here to talk about it as well. Bruce Waters, one of the organizers. Parisa Nozari, who did an amazing job. Tom Vassos, Caroline El-Khoury, and of course, never forgetting our very first astronomer in residence, Blake Nancaro, who's also come on this program a couple times. Blake actually started us off for the very, very first session, helped us get our live streaming up. So there are live stream images that you can watch from our astronomer in residence shows in 2022, and those are on the YouTube channel. So if you're following along over on online public viewing on the YouTube channel, you can actually go into the archives and see live imaging. And so this is really cool because, of course, the reason why I'm sort of, I suppose, maybe not overselling, but I'm emphasizing this site. It's a dark sky site. And having incredibly dark skies is incredibly good for astronomy. You can see the Andromeda galaxy naked eye. I mean, if your vision's okay, if you have reasonably good vision or glasses, but it's actually possible to see the Andromeda galaxy with your naked eye, and the Milky Way just pops right out. So having super, super dark skies with your telescopes means that you can get some really remarkable astrophotography and amazing views of things that just are much more challenging to see from here in the city. All right, so this is the point where I'm going to remind everybody. So this is where I'm reminding you all. You are in fact listening to York Universe, broadcasting live from Allan A. Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you want to find more about the Astronomer in Residence program, or if you want to see those Valentine's Day tickets that are tomorrow, so if you're listening to this as a recording, it's probably already happened, but you can go to yorku.ca/science/observatory. And you can also get to our online public viewing, which is happening right now on YouTube. For any kind of extra chats or questions, you can find us on, of course, all of the social media. And tonight, you're listening to Dr. Elena Hyde, and we're talking about all kinds of things out of order that are not part of our regular York Universe program. So we're doing a little bit of a different broadcast this evening. If you are interested in joining the chat, OPV is still going on live on YouTube, if this is live, and you can find it by going yorku.ca/science/observatory and clicking on the YouTube or the OPV buttons, or you can just go directly to YouTube and search for the Allan A. Carswell Observatory, York University, and that will get you straight to our YouTube channel, where of course we have all the recordings and all of that other really fun stuff. Okay, now it is time officially to get onto the interview portion. Oh my gosh, I can't believe it's time to start already. So we have a very special interview with Dr. John E. Moores. And Rob, this is where I'm calling in to our technician. We're going on to our interview portion now. Hello, everyone. We're here tonight with an associate professor from the Department of Earth and Space Sciences, Dr. John E. Moores, on York Universe. Dr. Moores has been a regular, actually, on this program, telling us all kinds of things throughout the years. As an associate professor, he has done many, many things, working with, of course, the Planetary Volatile Laboratory, supporting surface operations on Mars, my personal favorite planet, so wonderful wonderful, looking with the Science Laboratory rover and doing many other things as well. Now, I understand you have a new hat as the Space Agency's science advisor, so I'm going to actually have you tell us a little bit about that just to get us started here.
Sure, I'd be delighted to, and thanks for having me on the program, Elena. Great to be here. So, really, the whole idea behind the science advisor, and I'm the second one to hold this role, by the way, after Sarah Gallagher from Western, who was an astronomer, by the way. The whole idea here with the science advisor is that I've sort of got 5 different things that I take care of. So, first of all, is I actually provide science advice. So I'm advising the president, I'm advising the executive committee over at the Canadian Space Agency about all of the great things in science. I also represent and promote the Canadian Space Science Portfolio. So that means all sorts of things. It means talking on shows like this. It means fostering partnerships in space research and other government departments internationally, all that good stuff. And communicating the societal impact and breadth of the CSA's science investments. So really, I'm the principal public-facing science advisor for the CSA, which is a fun new role for me to be in, and one that I feel like this program maybe helped me to prepare for just a little bit, which was great.
Excellent. Well, and actually, one of the things you mentioned before was Canadian space citizen science, which I personally am a huge fan of citizen science projects. Are there any favorites that you have for Canada right now?
Oh, favorites. There's so many interesting ones out there, and I find it really interesting when people, as part of their everyday lives, get involved in science and help out professional scientists to really increase the breadth and scope of what they can do. There's also wonderful initiatives where the citizens, the enthusiasts, have really led the way, and scientists have only come to it later on. An example of that has to do with some of the auroral science that's taken place. There is a feature called Steve, I believe, that was something that citizen scientists saw first and then brought to the attention of others.
That's wonderful. I know that I personally have been using the Bit of Mars high-rise snippets a lot in my class. So doing some citizen science here in Canada, there's just so many interesting things we could possibly look at. And the observatory becoming robotic this year, we have a lot of possible crossover. So it's just very, very exciting times. Special shout out, I suppose, to Galaxy Zoo, who made a prominent appearance in one of my courses this year. So looking forward to doing a lot more of that in Canada. Now, of course, there's a lot going on in Canada right now for space. It's such an exciting time. We just had an announcement, gosh, it seems like it was yesterday, but I think it was a few months ago, about commercial space launch support in Canada. Are you aware of that announcement, or you have any thoughts on it?
I'm aware of that announcement, and don't feel bad, Elena. The term is really busy. It was actually only, I think, about 2 weeks ago that came out. I know, I feel it too. So the nice thing about this is you had a couple of different government departments getting together, the Canadian Space Agency and, of course, Transport Canada, which leads these sorts of things, and saying that Canada is open for commercial space launches. And the reason that that's important is because when you look at how the treaties work internationally on who's responsible for what when it comes to space launching, and in case anything ever goes wrong, it's the government of the launching state that is responsible for ensuring that the launches are, up to code and that everything is in order. And previously, we hadn't taken that step. So by taking this step now, it means that you can have these commercial launches in Canada, and there's a few places that have lined up to perhaps be the first to actually take advantage of that launch capability.
That's wonderful. I was reading something on this before where there is a little bit of talk about the type of launches that will be taking place. And I know that recently in sort of space news, we've seen a lot of these very advertised launches for SpaceX and Blue Origin sending tourists into space. But from my understanding, that's not exactly what this is going to be. It seems to be, and please tell me how wrong I am, that this is more for things like satellite launches and stuff like that.
Well, we'll have to see how things develop, right? There's all sorts of different launchers from all sorts of different companies with all sorts of different capabilities. I mean, it's interesting that New Zealand recently became one of these commercial launching states, but with very small rockets. And at this point, I don't know how big the market's going to get, or what size of things we're going to see, but usually things start small, and we do have a lot of experience with launches in Canada. The Churchill Range, for instance, in Manitoba, is one of the most widely used, or at least in the past, was one of the most widely used ranges for rocket launches anywhere in the world. So it's nice to see that coming back to Canada.
That's wonderful. Yeah. And of course, with smaller launches is not necessarily a bad thing. The technology that you can now fit into some of those shoebox satellites is really impressive. But of course, with space and space launches, we can't help but think about, as I say, some of the more big and glamorous ones. So I think I'm going to shift gears a little bit and talk about probably the biggest and most glamorous space thing happening right now, I mean, maybe other than JWST, the Artemis program. Because just recently we saw the success of the Orion spacecraft and the Space Launch System SLS rocket. The Artemis program is so amazing. What are your thoughts on that program and our progress so far?
Well, it's something that's really amazing to see. These big programs, they tend to involve a lot of different partners, so a lot of people can come along for the ride. While it is led by the United States, and these are launching from Florida typically, you do see a lot of collaboration, diplomacy in space, which is really wonderful. And the goal is wonderful as well, going back to the moon, building the lunar gateway so that there's a more permanent presence there, and then of course down to the ground as well, back to the moon for a different group of people than of course we had in the 1960s, a broader, more equitable group of astronauts. So I'm really looking forward to that. And of course, as you know, Canada will have an astronaut on Artemis 2, which will be coming up not too long from now.
Well, it's funny you should mention the not too long, because I keep checking all the websites and it still says 2024. How likely is it that we'll actually be sending astronauts around the moon in a year? What are your thoughts on that one? Because I'm just amazed that it still says 2024.
It's true, but the future usually arrives faster than you think.
This is true.
I mean, it feels to me like the shuttles were retired yesterday. But when you think about it, it actually has been a fair amount of time, enough time to, get everything lined up, develop the new technologies, test them out. So with Artemis 1, we saw that the capsule worked well. All of those systems had a good workout. The furthest a human-rated spacecraft has ever traveled from the Earth. And so the next step kind of is to, put some people on board and see how it goes. And I'm sure that it will be wonderful.
Oh, absolutely. I'm very much looking forward to it. I just very much hope that they're able to somewhat keep to that schedule, because that is so incredibly exciting. And the Artemis program, as you say, it has multiple steps. Artemis 2 is the fly around of the moon with astronauts, but then Artemis 3 is already a crewed landing, which is much more difficult. The moon landing missions are so incredibly complex. I don't think it's easy for a lot of people to picture the complexity that comes into going onto the moon and getting back off. I know that there were even some astronauts who notoriously got a bit lost trying to walk around on the moon because of the confusing nature of the geography. Hopefully that doesn't happen. But when we land on the moon with Artemis 3, do we have a way to get off of the moon yet, to get back up out? Because I heard that, at least when I was reading it, it seemed like they were still developing the lift system.
Well, I haven't seen the report that you're referring to there, but I'm sure that these are plans that are well advanced, and given the timelines that I would expect, testing wouldn't be too long for now. But we can certainly connect you with somebody who has more information on this than I before I start speculating madly here.
Yes, well, of course, so this is a radio show notorious for astronomy speculation. So I'll just go ahead and note that one of the reports did come back that at least the spacesuits are still in development and won't be ready until April 2025 at the earliest. So if you have seen Artemis 3 dates of, it's definitely not going to be until after they have finished testing the spacesuits. But it's very interesting times because, of course, they are not just utilizing the same lunar equipment that we had before. This is kind of a new system. It's a new crew vehicle. It's a new landing area. It's, of course, new spacesuits coming in. So we've got a lot of new technology that's been redesigned being part of this Artemis program, and it is really exciting times. I think that the most exciting piece of technology, of course, attached to this has to be the Lunar Gateway, because this is such a cool idea. I can't believe it's not been done before. The Lunar Gateway. So I think we'll go and talk about that one next. I know this is one of your topics as well. So why don't you talk a little bit about the Lunar Gateway for us?
Well, sure. And just, to comment on the complexity of it, you're right. I mean, spacecraft are amongst the most complex, if not the most complex things that humanity gets together to build. And when you think about it, we have a lot of advantages that we've gained since the Apollo era here in terms of the technology that we can use. I mean, it's just astounding to go back to the 60s and think, what they were able to do with what they had at the time. And here we are where everybody, has on their person in a cell phone something much more powerful than, they had for the entire program basically back in those days. So in terms of the gateway, that is a really neat environment that's going to be set up. Something that is a long distance away from the Earth, with ability for human beings to spend some time or to teleoperate things on the surface of the moon. And of course, Canada's making a big contribution to the Lunar Gateway in the form of Canadarm3, which will help things out a little bit. So we'll learn to live in space a little bit further from the Earth, outside of those Van Allen belts, deeper in space with a little bit of a light delay too. And that's going to be something that's going to be really helpful as we learn to take those steps further and further away from home.
Absolutely. And with this basically deep space habitat sort of element, it makes moon travel just so much easier in so many ways. Because if you have a space station, going up and down to a space station is a lot easier than going up, doing all your traveling and coming back down in one go. And we were talking about this, of course, on this very program a couple of weeks ago. So I just have to mention one of the things that is really appealing about this space station is that if you have a vehicle that can get up to the space station going around Earth, the International Space Station, the largest modular space station in low Earth orbit, it's not so hard. I mean, it's still quite technically difficult to get up to the space station, but there are now multiple Earth companies that have the technology to get up to our space station. Once you're there, it's not too hard to go from the space station to the moon if you had something there waiting for you, like the Lunar Gateway in orbit around the moon. You could then park there and take a different vehicle down to the moon. It all of a sudden becomes a much easier transport. And I mean, it wouldn't ever describe going to the moon as easy, at least not the next probably 50 years or so, but it opens it up in a way that would never have been possible in the Apollo era, where we were going, all the way to the moon and coming all the way back. So I just love the Lunar Gateway idea, and of course it's solar powered, and it's mainly a communication hub. But you could have people staying there for longer amounts of time, and you'd be able to study what happened to them, as well as of course looking at all kinds of different science experiments that you'd be able to do out there. Maybe we'll even put a telescope up.
And I think you really hit the nail on the head there. It's not that it takes less fuel or less, oxygen or food or anything like that to get to the moon when you have the Lunar Gateway. But it is a place where, like you say, you can cache things. You can have things available there potentially ahead of time, which is an advantage.
Oh, a huge advantage. And it's having things orbiting the moon, of course, if you do manage to get a little GPS set up, that will also help you prevent any astronauts from getting lost, which is one of many advantages. And of course, you mentioned Canadarm. So we have to talk a little bit more about Canadarm. This is one of the coolest robots I've ever seen. And Canadarm has played such a major role in, of course, the Space Shuttle and ISS. It's really not surprising that they would want to be using it now. But can you tell us a bit more? What do you know about the Canadarm, I should say, implementation in this case?
Well, it'll definitely be interesting how it gets used at the Gateway. So every time that a new one of these has come out, so we had, like you mentioned, Canadarm1, which was on the shuttle, Canadarm2, and Dexter, which was on the space station. There's always capability added to it. And so out of the Gateway, now we're starting to deal with that flight time delay a little bit. We're starting to deal with a station that might not actually have people on it all the time. And how do you conduct those kinds of operations in deep space with a robotic manipulator? So it gives some flexibility of being able to do things even when people aren't there. But also you really get to, a little bit more capability as you, build that station up, put things together and get it all checked out. So it's a new challenge, and it should be very interesting to see how it goes.
Absolutely. And if you haven't seen a picture of any of the Canadarms yet, I definitely recommend all of our listeners to go and look one up. These robotic arms are pretty cool pieces of technology, and they are quite a bit larger than you might be thinking. If you're just thinking robotic arm, you might be thinking of like maybe the Terminator's arm or something. This is a much larger thing with a lot more joints in it than a standard human arm, for example. It can have astronauts anchored to the end of it, as in the case of the ISS, and it can do a lot of things, especially helping with construction, building things on the ISS or in space. So this is a wonderful thing to have, and hopefully if it is used on the Lunar Gateway, it won't be the end of us building cool stuff in space for sure.
Oh, certainly not. Certainly not. There's call for robotics everywhere in the solar system. And I was involved many years ago on a spacecraft named Phoenix that landed in the Martian Arctic, and it had its own robotic arm out there to scoop up the soil and put it into the various scientific instruments.
That's wonderful. Yes, Phoenix was one of my all-time favorite missions. I still have the sticker for my laptop. Everyone should go and read about that. And of course, this was not on the moon. We've been talking a lot about the moon. Phoenix was, of course, on Mars. And if we're talking about, of course, landing on the moon, Artemis mission, and Canadarm implementation, one of the possible goals of building our presence up on the moon is this whole moon to Mars idea, which is how we can get to Phoenix from our current conversation. So we could, if we're going from the moon to Mars, it makes sense to use a lot of this same rocket technology, a lot of the same, of course, robotic technology. It'll be wonderful, of course, to have commercial space launch support here in Canada, if that happens. But there's a lot of difficulties in going from the moon to Mars, and not just the distance. What are your thoughts on getting to Mars after the moon?
Yeah, and I think we need to be careful about how we describe that, because I think, what we mean when we talk about Moon to Mars is, we're going to learn lessons. We're going to learn ways to live in space, ways to operate on the moon. And it's that knowledge that we'll use to get to Mars. We would not likely want to take a spacecraft from the Earth to the moon and then from the moon to Mars, because that costs a lot more fuel than just going straight to Mars from low Earth orbit. So, I think there is value going back to the moon. It's kind of our playground a little bit. It's, in our neighborhood. So it's relatively easier to learn some of those lessons there, see how our systems perform, see, where they break, if they break, and to find good fixes for that before you go off to Mars, where you might actually, you would be a long way from support, and you might have to wait until the planets align again before you're able to get home. So you might be there a while, and you'll want to have good know-how with you as you're doing that mission.
Absolutely. And of course, that's a real key one is, the moon is, as you say, our a much closer target, and it's never all that far away. However, Mars, being an entirely different planet on its own orbit around the sun, it could end up on the opposite side of the sun from the Earth. And if that happens and you're on Mars, you're going to have a tough time getting back to Earth should you want to. You're probably just going to have to wait.
Absolutely. Yeah, and when you think about it, you're going up to low Earth orbit on the International Space Station. If there's an emergency, you typically have a Dragon, a Soyuz, you have some space vehicle, and you can be back down on Earth if you had to be relatively quickly, minutes to hours, depending upon the nature of the emergency and how you did it. For the moon, it's more like 2 or 3 days is what you're talking about in order to get back. But for Mars, it could be 500 days, depending upon what exactly you've brought with you, how the orbits of the planets align for your particular mission. It's a whole other ballgame when it comes to really remote operations.
Yes, exactly. Well, that is, of course, why a lot of people have been suggesting that if we go to Mars, we should try to go there in as permanent a fashion as possible, because you kind of do need to have everything there if you're going to be there. You can't just hop on a rocket and get back to Earth. But, building a lot of stuff on Mars is going to be quite tough.
Oh, definitely. And this is way, way in the future. But this idea of in situ resource utilization is called, or ISRU, where you actually use local materials to help you to survive. That's something that we work on even today. We're issuing grants and contracts and things like that to investigate potential future technologies, just to get that started. And in fact, the Perseverance rover, which is currently on Mars and trundling around in Jezero Crater, it's got a couple of those ISRU experiments on board. For instance, the MOXIE instrument, which generates oxygen.
Yes, and yet is definitely something you would need on Mars, because you cannot breathe the air. This is one of the great advantages of being on Earth. If you are a human, you need certain amounts of breathable air and atmospheric pressure to survive. Mars doesn't necessarily have any of that, so you would be looking at creating contained environments and having a lot of resources. But one of the early pictures I did see from Mars habitats was this idea of using that loose Martian soil. If you could build a robot, so we're talking about robotics, maybe the future Canada arm will be a Canada Mars arm. If it can 3D print Martian soil, then you could actually 3D print structures in situ on Mars. And there's some wonderful sci-fi drawings of them up. It's a long ways away, though, I'm sure.
Oh, absolutely. I love the science fiction that was made, especially in the early 1990s when this was really a topic. How do you build things? And, regolith is pretty good for that. We talk about it for the moon as well. You put a couple of meters of that on top of a structure, and now you have insulation from the most damaging radiation sources that you run into in both of these places, because they both lack a significant atmosphere or an ozone layer.
Yes, and lack of magnetic field as well, I'm sure.
Yes.
And that is actually really interesting because you mentioned earlier lessons we can learn on the moon. One of the great ones is, of course, that famous moon dust encountered, I should say, by Apollo astronauts was incredibly fine, I believe, and very pervasive. And if you're going to be using that, that it seems like at least quite different than materials we're used to using here on Earth. Mars is also a very dusty place. So if we can learn how to deal with moon dust, maybe that in turn might help us later with our Mars dust problems.
Oh, absolutely. The moon dust, I think, is the nastiest stuff out there in terms of these sorts of things, because it's really angular. And sure, they get into things, they can spoil your gaskets. They got all over the astronauts' suits back in the 1960s. And really, it's the lack of water that does this. We'd hope that Mars wouldn't be quite that bad, but it's a gap that we have in our knowledge now, one that we're trying to close.
Yes, and the lack of water, hopefully, will be also something we'll be learning how to deal with on the moon. Of course, Artemis 3 is the one where they're going to land. I think the south pole of the moon was where they found some water ice that they're going to be investigating. So there's just so many interesting things happening in this space. It's really fun stuff.
Oh, absolutely. Yeah, there's a number of craters where there seems to be water ice under the surface, and maybe even some frost over top from the Lunar Reconnaissance Orbiter. They had some instruments that suggested the presence of frost. I'm looking forward to some robotic exploration to actually, take a peek at that and confirm the water.
Absolutely, more robots. So I think we'll go ahead and wrap up this interview with any final words from you. What are your ideas for sort of our next steps and most things that make you the most excited about all this?
Oh my, there's just so many wonderful things happening in space for Canada, and you really see that ramp up. Things like Artemis, things like being able to support commercial launches, and we actually see it on the Earth observation side as well. We just recently had a mission where 14 universities got together and created a couple of satellites that'll tell us a lot about the upper atmosphere. It'll actually figure out a few things that we don't know right now about how our own planet operates, and that are really critical for understanding how climate change works too. So there's amazing stuff. It's happening every day. It's the most wonderful thing that I've seen since I started this role. And I can't wait for the next couple of years.
Absolutely. Well, I definitely agree. It is an amazing time to be in astronomy and in science. And as I always tell people, don't forget to look uppity, because you can actually see some of these things. Mars is in the sky these evenings, so feel free to, as is the moon, so feel free to spare an extra thought when you go out stargazing, maybe this evening. Okay, excellent. Well, thank you so much, Dr. John Moores, for coming by today. This will be the end of our sort of official interview section. It's been wonderful having you on again, and we'll go ahead and say hope to have you back again soon, and clear skies.
Thank you so much for having me.
You're listening to AFM Radio on astronomy.fm.
To see the earth as it truly is, small and blue and beautiful in that eternal silence where it floats, is to see ourselves as riders on the earth together, brothers on that bright loveliness in that eternal cold.